I'm going to do a quick run through on how I experiment with an LLM. What I'm doing is the 5 whys problem. I insert the question here, and then it goes around the loop 5 times and comes out here. So this is the first LLM. It produces an answer. We go into a little piece of Python that says, has it been 5 times or not? If it hasn't been 5 times, it pumps the answer that it got back out to here. This thing rephrases the answer as yet another question, then pumps it back out, feeds it back into the first LLM, and then the first LLM goes through the loop again until it's finished, and then the final answer comes out here on out.md. We can look at this part. It's in this tab. So we're looking at this tab main. We can look at rephrase answer as yet another question. And here it's just doing the same thing. It's feeding a string into the LLM. In this case, I'm just using an LLM written in Go. It's called agency. And we just concatenate 2 strings together. The first string is this string that says rephrase each issue as a concise question, ask for concise answers. That goes into pin port 1. And then the original answer comes into port 2. They get concatenated together into a longer string, and that comes out here and then gets fed into the LLM. And then the LLM rephrases it and pumps it back out. As it pumps it back out, it also cycles the new rephrased question back onto the reset port, which just resets the string concatenator to waiting for something on 1, then 2. Now we can go to the terminal to show how this works, and we first do a make init. That installs some of the dependencies that we do make LLM. This also has to be done only once to build the CLI version of the LLM, and then we just run make. And what's happening here is that we've taken this diagram that we were looking at here, this diagram, and turned it from LLM.draw.io format into LLM.draw.io JSON. We remove all previous attempts at this, and then we run this Python line, which asks the question. In this case, I'm asking the question, is concurrency considered difficult? I'm using the main tab on the diagram, and then I'm using the JSON that was converted earlier, and then I'm pushing it through an output splitter. And what we're watching is the turnaround time on this is several seconds per round. We've counted up to 3 now, 4 times through the loop. We've gone through this, back to here, back through this loop 4 times now. The 5th time, it should come out here, and it did. And it says appended to out.md, and then if we go to out.md, there's the response that came from the LLM, with 5 times reworded. The point of this, I've written it up in the README file for this file. Basically, this is just a technique for if you're a consultant and you want to find out what the real problem is. You ask a customer. The first time around, the customer usually can't give you a really good answer. You take the answer, put why in front of it, basically, and ask it again. And you keep doing that 5 times, and about the 5th time, you start getting to the actual nub of the problem. We can look at the make file. I'm not going to read this, you can. Make file, spelled with a capital M. Okay, so we've cloned this project from PBP Kit, which I show how to do in the first short video of this series, where I just do hello world. We set the name to LLM. That gets jammed in here and in here. And then there's a procedure for doing the init, which we just saw. There's a procedure for making the LLM, the Go code. And then there's a procedure for doing what we just looked at. And these other 2, logic and logged, I'm going to show in a moment. They're basically the same with slightly different diagrams. Logic.draw.io and logged.draw.io. Same question in all cases, same procedure in all the cases. The logic one is just a quick way around the loop. We stub out the LLM. We'll look at main.py. Main.py basically imports the kernel, imports two small Python files. I'll show you them in a moment. It creates a palette and environment by calling the kernel with the argvs from the make file. It then installs the two count and replace new lines, and then it just runs the whole thing. And when it gets back, it creates the thing, and then we inject argv2 into the nothing port, here. And then it runs, and then when it finishes, it does a finalize, which prints the output, and then the output gets thrown into the splitter here, and then the splitter just creates the one out file for every output that there is. And in this case, there were no errors, so there's no file created for that. Now we'll go to the stubbed out version of the loop, and I wanted to stub out these two LLM calls. I named them differently, TA and TC, just so that I can debug them easier. You'll see they're just straight through stub outs. And I've put little labels on the pins here just to show what I think should happen. What I expect to happen is, I should see a 1 come out, then I should see 2, 3, 4, 2, 3, 4, 2, 3, 4, and then finally a 5. And so now, here I've just got these labels in yellow. If I put actual parts on these to do probing, then this is the actual logic diagram. These are the probes. Normally I would just stick the probes right on the inputs. Here I would just take this output and jam it into the probe, so I don't need this. But it turns out these responses are so long that they fill the screen, and I don't want to look at all that stuff. I just want to see a number come out. So what I'm doing is I'm taking the response, splitting it into two places. It goes here and here. This leg just triggers this string generator. The string generator just generates the string 2 that gets jammed into the probe, and we see the number 2 come out on the screen. Likewise for all these others, normally it's not as busy as it looks here. So what we should see is the original message goes into TA, and it goes in and produces a 1. We should see that. The stubbed out part will just send it directly to the output. The output will get split to here and to here, and we'll see a 2 come out. And then count will do its thing, and it should, the first 4 times, come out here. So we should see this output get split twice. So we should see a 3. It goes to this stub out. This stub out just comes out here. It gets split again. We should see a 4, and that question comes to here. This is really just checking to see that the logic is fairly sound without bothering to wait for the LLM to give us a response, and without paying a few pennies or whatever it is for each LLM call. And we can try that out. We'll clear the screen. Make logic bang. Goes very quickly, and we see 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 5. Exactly what we expected. 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, blah, 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 around the loop a couple of times, then back out here, and then we see the 5. During debugging, I wanted to see what these intermediate responses were. So we jammed the answer into this LLM, and then this LLM rephrases the question and pumps it back into the first LLM. I wanted to see if the rephrasing was making sense, and so I added a logging part attached to here. Basically, when we come out here, I've taken off all the debugging probes, and just taken the original schematic and added this probe part here, log intermediate rephrasing. We can look at that. And basically it just calls a little Python file. The input here gets split into two places. It gets fired into this and fired into that. Because there's propagation delay happening here, the response will, the rephrased question will enter here, and then this line of tildes will get fed into this replace NLs. Look at count.py. There's how you build a counter in this. Basically, it's the same routine. Import the kernel, and then do all the stuff you need to do to build a counter. Basically, this handler gets fired every time an event comes in, and then it does the counting. This other stuff I explained in the previous video. You need to install a template, and then when it's time to load the system, we instantiate the components. And then we'll look at replace new lines.py. That's even simpler. Here it's just basically a text.replace. Take the tildes, turn them into new lines, just so that the intermediate stuff is more readable. And now we can try that. The logging out, make logged, and that will go to the LLM, so it's going to take a little bit of time. There's count equals 1. We'll wait for it to get to count equals 5. And when this finishes, we expect to see a file out.md and out.0.md. Out.0.md will contain the logging, the intermediate responses. And because there's 4 of them, we stick the tildes in between. Those get converted into new lines. It just makes it more readable in the big pile of markdown that we get in the end. And then we get a bunch of messages saying we're appending to out.0.md, which is this output. And then we created the final output file out.md. So we can look at out.md. There's the response this time, and because it's an LLM, the responses are slightly different every time through. And if we look at out.0.md, we see the cycle of re-asked questions. So what makes state management complex, blah, 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 comes around again and says, what complicates state management? And we can see here in this run, we need to check to see whether this is doing what we actually want. It looks like it's gone around and it has come up with the same set of questions each time through. So we need to check this loop and see that it's doing what we want it to be doing. This is just an experiment, so we can carry on with this. Of course, you can clone this result and play with it yourself if you want. The instructions are in the README. It basically gives a big backgrounder on what this technique is about, what next steps can be done in this experiment, and then it refers to the API document for creating Python parts.